My dear students of class 9, I am going to start chapter 14, name of chapter Statistics, exercise 14.3. Question number 3. Given below are the seats owned by different political parties in the following outcome of a state assembly elections. Political party A, B, C, D, E, F and seats owned A 75, B 55, C 37, D 29, E 10 and F 37 seats. Question number 1. Draw a bar graph to represent the polling results. 2. Which political party own the maximum number of seats? Question number 1. For the solution of this question, we write here political party is variable and seats own is its value. So we put political party on horizontal line, that is x-axis, and seats own on vertical axis, that is y-axis. Here we seat A has 75 seats. So this rectangle has height 75. Seat B, it has 55 seats. So B, the height of this rectangle equals to 55. C has 37 seats. So height of this rectangle will be 37. D has 29 seats. So height of this rectangle will be 29. E has 10 seats. The height of this rectangle is 10. F has 37 seats. So height of this rectangle, this bar, is 37. Here we write a scale. On y-axis, 10 a small division equals to 10 units. That is 10 seats own. Here we write party and arrow mark in x-axis and number of seats on y-axis. We do the arrow mark here for the representation. Now question number 2. Which political party own the maximum number of seats? So here we see party A has maximum height and its height is 75. So it has 75 seats. So party A own maximum number of seats. This is the answer of question number 3. Question number 4. The length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is represented in the following table. In column number 1, length in millimeter, and in column number 2, number of leaves. 118 to 126, 3 leaves. 127 to 135, 5 leaves. 136 to 144, 9 leaves. 145 to 153, 12 leaves. 154 to 162, 5 leaves. 163 to 171, 4 leaves. And 172 to 182 leaves. In question number 1, draw a histogram to represent the given data. Question number 2, is there any other suitable graphical representation for the same data? Question number 3, is it correct to conclude that the maximum number of leaves are 153 millimeter long? Why? For the solution of this question, we write for question number 1, we can only represent a continuous data on a histogram, that is, data in which upper limit of one class interval is equal to lower limit of next class interval. As here data given is not continuous, so certain adjustments are required in class intervals to make data continuous. Now here difference between upper limit of one interval and lower limit of next interval is 1. So adjustment required equals to 1 by 2. When we divide 1 by 2, we get 0.5. Thus, 118 to 126 can be written 118 minus 0.5 to 126 plus 0.5. This equals to 117.5 to 126.5. Similarly, other intervals are 126.5 to 135.5, 135.5 to 144.5, 144.5 to 153.5, 153.5 to 162.5, 162.5 to 171.5, 171.5 to 180.5. Now we draw histogram by taking length in millimeter on horizontal axis, and that is x-axis, and number of leaves on vertical axis. Since length in millimeter starts from 117.5 millimeter, we take a kink in horizontal axis, that is x-axis. This is kink in x-axis. We write length in millimeter in x-axis and number of leaves on y-axis. Here a scale. On x-axis, 10 small division equals to 9 units, that is 9 millimeter in length. On y-axis, 10 small division equals to 2 units, that is 2 leaves. Here 117.5 to 126.5, number of leaves 3. So we write here this rectangle has height 3 up to 3. 126.5 to 135.5, number of leaves 5. So height of this rectangle is up to 5. 135.5 to 144.5, number of leaves 9. So height of this rectangle is 9. 144.5 to 153.5, number of leaves 12. So we write the height of this rectangle is up to 12. 153.5 to 162.5, number of leaves 5. So height of this rectangle is up to 5. 162.5 to 171.5, the height will be up to 4 because number of leaves 4. 171.5 to 180.5, number of leaves 2. So height of this rectangle should be 2. This is the histogram. In histogram, there is no gap between the rectangles, between the bars. This is the answer of question number 1. Question number 2. We can also represent this data on a bar graph more suitably. On x-axis, we write length in millimeter, and on y-axis, we write number of leaves. Here, bar graph has equal spacing between the rectangles, and the width of each rectangle should be uniform. Equal spacing between the bars and uniform length of each rectangle. 118 to 126, number of leaves 3. So height of this rectangle is up to 3. 127 to 135, number of leaves 5. So height of this bar is 5. 136 to 144, number of leaves 9. So height of this rectangle is 9. 145 to 153, number of leaves 12. So height of this rectangle is up to 12. 154 to 162, number of leaves 5. So height of this rectangle is up to 5. 163 to 171, number of leaves 4. So height of this rectangle is up to 4. 172 to 180, number of leaves 2. So height of this rectangle is 2. This is the bar graph. Question number 3. It is not correct to conclude that maximum number of leaves are of 153 millimeter, as 12 leaves belong to interval 145 to 153, this rectangle, and not to 153 millimeter alone. It may be possible that not even one leaf has height 153 millimeter. This is the answer of question number 3. This is the last question today. I will meet you next day with another set of questions. Thank you. Thank you very much.